there is a nice version of the talk that he will talk in his blog, and it's Evan Lowing. And we will hear about a measure for rebounds.
LINHAC creating a statistic to predict rebound quality. So to start, I wanted to show a video on why rebounds are important in hockey. So in this video, we're able to see more than just the usual counting stats that you'd see in like a box score. So we're able to see 2 shots, an assist, and a goal. But what we're really seeing here is a player intentionally use a rebound off the goalie so that they can create a scoring lane for their teammate. They don't have that passing lane at the start, as we're able to see here, but they are able to create a shot and a rebound for their teammate where they're able to score. So that's why rebounds are so important in NHL games, and they've almost doubled in the past few years from about 3.5 to over 6 rebounds per game. So rebounds can be both intentional, as we saw in that video, or they can be unintentional, where a player is trying to score, but the goalie saves it and leaves a rebound in some kind of area where one of their teammates can finish off the job. So the goal of this project is to find the quality of each of those rebounds, and once we determine that quality, be able to see who the players are that are able to use rebounds to their advantage. So this will be created using a 3-step approach. First, an expected rebounds model will be created. This will be the likelihood that any shot will result in a rebound. Next, an expected angle model will need to be created. This will be the shot after the rebound, what that angle is at. Lastly, an xReboundsPlus metric will be created using the previously created models. So for this, we're going to need a lot of data. Luckily, MoneyPuck is able to have this data for us. So on that website, they have a lot of different shots. They have shot data going back to before 2010. Specifically for this, the 2023-24 shot data was used, and that was used for all the training on this. Additionally, there were about 120 variables in this data set, but only 8 were used for this analysis, as those were the 8 that pertained mostly to rebounds and scoring in this scenario. Additionally, I wanted to just point out that we are using the rebound definition for MoneyPuck, which is just if there's a shot and a rebound's given up and another shot within 3 seconds, that's considered a rebound. So first off, what needed to be created was the xRebounds model. So an XGBoost model was selected for this due to the fact that it can classify well and at a relatively fast pace, and it's worth noting that k-fold cross-validation was used instead of the traditional training and test set. This allows us to get the most out of the data so that we could create the best model possible. The variables that were used for this model were the readjusted shot distance, the angle of the shot, the type of shot, and the handedness of the shooter, and if the shot came off of the rush. And in the top, we're able to see the first iteration of the model. Fortunately, it looks like it did pretty good just based off the accuracy, but it didn't. What we're seeing there is it classified everything to be not a rebound and nothing to be an actual rebound, which is what we really want to study in this. So different parameters were tuned on this. Mostly for this, one of the more important ones was there was a class imbalance between rebounds and non-rebounds. There are about 12 times as many non-rebounds as rebounds in the data set. So from that, we need to adjust for that class imbalance. Additionally, some other things that were tuned were the learning rate, or ETA, when doing the R code for it, and the maximum depth, among a couple other things. After that, about 5 models were created, and the final one can be seen at the bottom there. This had about an 81% accuracy rate, which isn't as good as the original, but the original didn't actually have a usable model, as it didn't actually predict anything to be a rebound. So we are going to move forward with that final model seen at the bottom there. So after the xRebounds model was created, next stop was the expected angle model. This one was a little bit more tricky because we're using, instead of having the classification binary of rebound, not rebound, we're having the continuous of anywhere from 0 to 360 based on where it could be. The variables that were used for this were the original shot angle, the original shot distance, and the shot angle of the rebound generated by the original shot. So what we're looking at there is a shot was taken, a rebound, and then what's the shot angle of that rebounded shot? So due to the fact that this was going to be very tricky, as there were some missing pieces there, we're not able to see any elevation of the puck, where the puck was going to hit the net. I thought a neural network would be best on this. Unfortunately, that didn't converge. So next steps on that were the random forest, XGBoost, and linear regression models. Unfortunately, none of those were able to yield usable models, as all of them had not all the residual versus fitted plots weren't great. All of them showed a clear pattern. This can be seen in the top here. This one was not usable. This was one of the ones for random forest, I believe. All of them yielded residual versus fitted plots like that, so they were not able to be used. After that, a Bayesian regression framework was used, and two models were created. Then they were, with the difference being the interaction term, and they were compared using leave one out cross-validation, and the second model ended up being better. And then the residuals versus fitted can be seen there. So after that, we need to move on to the xReboundsPlus to tie it all together. So for the xReboundsPlus, we need to create a subset of the original data frame that was able to show both the original shot and the rebound, so that we could actually see what would happen with each shot. So what we had here was the X rebound value from the original shot, the expected angle of the original shot, and then for the next shot, we had the distance of that rebound, how far that rebounded shot was from the net, and if the shot after the rebound was a goal. This was just to show if that exact shot were to happen again, would that result in a rebound? Would that result in a rebound, and would that rebound result in a goal? So again, XGBoost and K-fold cross-validation with 5 folds was used. And then the final confusion matrix was used. There was some tweaking of the parameters on this so that we could get a better model. There's about an 81% accuracy with this, so not the best, but we are feeling fairly confident moving forward with this. So after all of that was said and done, we need to apply it to the current data set. So this was for the 2024-25 full season. So this was only for the regular season, not for the playoffs. At the top, we can see Brady Tkachuk, Matt Boldy, and Nathan MacKinnon. All of these were the top 3 for xReboundsPlus. Next to it, we can also see the xRebounds, and from there, we can also see the shots. At the end of the top 10, you can also see Zach Werenski and Cale Makar. So there were some defensemen at the top of the list, but they were generally taking shots from closer out where goalies have a better chance of tracking it. So oftentimes that leads to less rebounds. So after completing that, just need to talk about some possible improvements to the model. So some of those include the data as I talked about before. So we're taking a 3-dimensional game and we're squishing it down to 2 dimensions. So we're not really going to be able to have the same kind of accuracy that we would without those missing pieces. Additionally, some pieces of some goalie positioning and maybe even other goalie specific data could improve the model even more. Additionally, the X angle model wasn't able to improve the X rebounds very much, as X rebounds in xReboundsPlus had a very high correlation. It was over 0.9, so not as great as we would like to see. Possibly using something like a physics-based model, which I don't have much experience with, would be better for creating the expected angle. But overall, this project was able to meet the original goal, as a new metric was created that was able to quantify rebound quality, and hopefully it can be improved upon in the future. If there are any questions that we aren't able to get to, feel free to contact me at my email, elong1018@gmail.com, or you can follow me on Twitter at EDLAnalytics. Thank you for listening.
Also, Ivan is online if there are any questions. No direct questions. Thanks, Ivan. Thanks, Louis, also for being online in the middle of the night.